Today I am going to discuss about Newton's forward difference method. Here is the Newton's forward difference formula. So f of x is equal to f of x0 plus p del of f x0 p minus 1 by factorial 2 del square f of x0 plus p minus 1 into p minus 2 by factorial 3 del cube f of x0, so on, where p is equal to x minus x0 by h is equal to step size, del is forward difference operator, and x0 initial point. Now here del of fxi is nothing but f xi plus 1 minus f of xi. Del square f of xi is nothing but del f of xi plus 1 minus del f of xi. Del cube f of xi is equal to del square f of xi plus 1 minus del square f of xi. So now here the data is given, and from this data, so temperature data and vapor pressure data are given. From that data, using Newton forward difference method, we have to calculate the pressure at T is equal to 27.5 degrees centigrade. So that we have to calculate, means pressure we have to calculate at T is equal to 27.5 degrees centigrade. Now, so first we have to make that forward difference table. So here, so first, so these are my x data and these are my the f of x data. So this we have to calculate del f of x0 x, and that is del square f of x and del cube f of x. We have to calculate that. Now from that, first how to calculate del of fx? So we have to subtract from here to here. So 12.7 minus 10, so that will get 2.7. So then next 16.1 to 12.7, 3.4. Next this, okay, 20.2 minus 16.1, that is 4.1. Next is this, these two data will get this data. So 25.2 minus 20.2, that is 5. Next we have to calculate from the del fx. From this we calculate del square fx. So from these two data, 3.4 minus 2.7 will get this data. From these two data will get 4.1 minus 3.4, that is 0.8. From this data we'll get 5.0 minus 4.1 will get 0.9. So now similarly we'll get del cube fx from del square fx. So if we subtract 0.8 minus 0.7, we'll get this, and we subtract 0.9 minus 0.8, we'll get this. Now here for interpolation at T 27.5 degrees centigrade, so that interpolation we are going to calculate at T 27.5 degrees centigrade. So we'll use starting point is this, and then value we will take. So this value will take, this value will take, then this value will take, then this value will take. Based using that, in that formula we'll use that value to calculate the vapor pressure. Now here, so T we already know that we are going to calculate pressure at this point 27.5. x0 is our starting point, that is 25 degrees centigrade. H is the tape size, that is 5 degrees centigrade, and P we can calculate x minus x0 by h. We plug that and we will get 0.5, and values from the table we already know from the previous slide. Now we plug all this value to the formula. So here this is the formula, so we plug this value. So f of x is f of x0 plus p del f of x0, p into p minus 1 by factorial 2 del square f of x0, p into p minus 1, p minus 2 by factorial 3 del cube f of x0, plus so on. So now this value is nothing but 12.7, p is 0.5, and this value is 3.4, p is again 0.5, p minus 1 is minus 0.5, and del square f, that is 0.8, p again 0.5, p minus 1 is minus 0.5, p minus 2 minus 1.5, and del cube is 0.1. Now here we are calculating first term is that 12.7, second term will give 1.7, third term will give minus 0.1, and fourth term will give 0.00625. So after getting all this value, we can calculate the vapor pressure. So we got 12.7 plus 1.7 minus 0.1 plus 0.00625. After doing the calculation, we will get the pressure is 14.30625 kilopascal. Now here the result verification. So result lies between adjacent value, that is 12.7 and 16.1 kilopascal, follows expected vapor pressure trend. So if you check that we got the pressure in between the range, and magnitude of the successive term decrease. You see that, so here this term is decreasing in the order. Okay, so that is also we observe, and then physical significance maintained. So that's about Newton forward difference method. That's it. Thank you.